Hey guys, Assalamu alaikum. Here I'm going to start a new concept today, and that concept is related to elements, compounds, mixtures, atomic structure, and this whole thing will be leading towards the next topic that is called bonding, which is making a major base towards your subject. Before moving ahead, I would like to bring your attention to all those previous topics on which I have already made different types of videos. One of the topic was related to kinetic particle theory. The next was related to diffusion, which is an application of kinetic particle theory. Then I have introduced you to the different types of the apparatuses, their uses, and then we have collected the gas and dried the gas, high upward delivery, downward delivery, etc., etc. Afterwards, we move to the purification techniques, melting point, boiling point, paper chromatography, and then the separation methods, physical methods for separating the things, for separating the substances which are might be insoluble into each other, might be soluble into each other. Fractional distillation was the advanced most technique which we have studied in detail. Right now, I am leading you to the next topic, and that is called element, compound, and mixture. Here, let me write down the heading first of all. It is element, compound, and mixture. Okay. Now, before moving ahead, you people should know some of the definition very clearly. Sometimes examiner is asking these definitions exactly and directly. Okay. An element is a pure substance. An element is a pure substance which cannot be divided further. So, for example, if we have one block of iron, okay, we are saying that this is made up of iron, okay, and now we are going to divide it into smaller particles. We have passed it through a crusher, and the smallest particle is this. For example, I have just drawn a very small particle. So what is the composition of this particle? This is again made up of iron. We cannot say it is something else. It is again iron. So when we have a block of copper, we are going to divide it into smaller particles. The smallest particle will be of copper. For example, we have one cylinder of oxygen gas and we are taking one particle out of that cylinder. That particle will be of oxygen gas. So it means that an element is a pure substance. It cannot be divided further. It is remains same, you may say. Okay. Now, the next definition is related to atom. And what is an atom? It is the smallest particle of an element which can represent all the properties of that element. Okay. Sometimes some students have some wrong definition in their mind. And what is that? I'm telling you the wrong one now. That an atom is the smallest particle of an element which cannot be divided further. It is a wrong definition. Okay. So what is the right definition? I'm repeating my words, that an atom is the smallest particle of an element which can represent all the properties of that element. Okay, so let me write down the definition as well. Smallest particle of an element which can represent all the properties of that element. Okay, so this is how we are defining an atom. Okay, let me take you to the next page. After this, I'm telling you that an atom has basically two parts. And what are those two parts? One of them is nucleus and the other is electronic shells. Okay, now what is this? Nucleus is the central part of an atom. I will try to draw a diagram as well. And these are the pathways, which we are right now drawing like a circle type of thing. Okay, they are basically not in the exact circle type of thing, somehow matching with that of a circle, but right now we are going to draw it in the circular form. Okay, so what are these electronic shells? Pathways. Where pathways? Pathways around the nucleus in which electrons revolve. Okay, so guys, this is the nucleus, for example. Okay, so this is the pathway number 1. This is the pathway number 2. This is the pathway number 3. So this is just telling you that nucleus is in the center and these are the pathways around the nucleus in which electrons are revolving. How many pathways will be there? It depends upon the number of electrons. We should now know only one thing, that every atom has a different number of electrons. I must say every element has a different number of electrons. We are going to discuss it shortly in detail. But right now, I have just told you that an atom is the smallest particle of an element, which can represent all the properties of that element. And number two, that an atom can be divided into two basic components. One of them is the nucleus, which is the central part, whereas the other is the electronic shells, which are around that nucleus. All right. Now I'm taking you to the next page, and that is related to the definition of certain points, that is certain elements are divided depending upon their combination of atoms. Okay, so I am giving it a heading. What is that? Types of atoms, or you may say types of elements depending upon their combination of atoms. Okay, so number 1, monoatomic elements, those elements which are existing in the form of a single atom. Okay, those elements which are existing in the form of a single atom. So mono means one, you already know mono means one. Okay, single atom. What are the examples of the single atom elements? What are the examples of the single atom elements? Number 1 is all metals. Where are the metals in the periodic table? That I am going to mention very shortly, inshallah. So all metals and all the elements of group number 8. Elements of group number 8. Now, what are the elements of group number 8? Helium, neon, argon, xenon, krypton, radon. These are the elements of group number 8. These all elements are in the form of a single atom, and all the metals of the periodic table are also in the form of a single atom. Now, what is the next type? And that is called, here I am writing the next type, and that is called number 2, diatomic elements. Diatomic elements, those elements which are existing in the form of two atoms together. Okay, those elements which are existing in the form of two atoms of that element together. So for example, here I'm writing two atoms. So there are few examples for this. All elements of group 7 plus oxygen, nitrogen, hydrogen. Okay, so whenever we are asked to write the formula for oxygen, it will be O2. Whenever we have to write the formula for hydrogen, it will be H2, N2 for nitrogen. So what are the elements of group number 7? Here I'm writing fluorine, chlorine, bromine, iodine, and astatine. Okay, guys, sometimes the students get emotional. I don't know what happened. So they are writing FL for fluorine. This is not FL, this is F. Okay, please be careful about that. Cl, and they are, I guess they, from Cl they are writing FL. This is F only, stands for fluorine, whereas Cl stands for chlorine. Astatine is a different type of a name. Sometimes students are finding it a little bit difficult or somehow like that, but if you will try to pronounce it like 2 or 3 times, then it can be in your mind. And what is that? Astatine. Okay, so AT is the symbol. Once examiner has asked a question related to the bonding in astatine, that I am going to teach you when I will teach you the topic of bonding. But please keep this thing in your mind right now. So oxygen, nitrogen, hydrogen, and all the elements of group number 7 are naturally diatomic. What is the meaning of diatomic? They are existing in the form of two atoms together. Okay, right now I am taking you to the next type, and that is the type number 3, and that is polyatomic elements. Okay, now what are the polyatomic elements? Those elements which are existing in more than one atom. Okay, in the form of more than two atoms, I must say. Those elements which are existing in the form of more than two atoms of that element combined together. Okay, so I'm writing here more than two atoms are combined. So for example, P4, what is P4? It is phosphorus. S8, that is sulfur, and O3. What is the difference between O3 and O2? In O2, two atoms of oxygen are combining with each other, making that oxygen gas in which we are respiring. And what is O3? In which three atoms of oxygen element are combining with each other, making the layer of ozone. Guys, remember that thing, that there is a layer of ozone. Ozone formula O3. Ozone is a gas. Ozone formula O3. It is making one of the layer in our atmosphere, and that layer is basically used to stop the ultraviolet radiations from sun. As as this layer is stopping the ultraviolet radiations from sun, preventing it to reach from earth. As a result, it is saving us from skin cancer. Okay, this is some information which is important regarding your syllabus point of view. So I am just telling it to you right now, only this point, that O3 is making ozone. Now I'm changing the page to the next board, and that is the definition of a compound. Okay, what is a compound? A compound is a chemical combination. Okay, what is a compound? It is a chemical combination of two or more than two elements together. Chemical combination of two or more than two elements together. Okay, so basically there are two types of compounds. Number one is ionic compounds, and number two is covalent compounds. Ionic compounds are those which are formed by the combination of metals and non-metals, whereas covalent compounds are formed by the combination of non-metals and non-metals. Okay, so inshallah we are going to continue this topic further from the same page. Inshallah, take care of yourself. See you in the next class.